Okay, so this is graphing ellipses. Graphing an ellipse is very similar to graphing a circle because ellipses and circles are cousins, like squares and rectangles are cousins. Actually, a circle is an ellipse. It just happens to be a perfect ellipse. So the working form for the equation of ellipse looks like this. X minus h squared plus y minus k squared. So that looks like a circle, right? But for an ellipse, you're going to have fractions. And instead of being equal to the radius, it's going to be equal to 1. Your center point, just like a circle, is going to be at the point HK. And then, because we don't have a radius in an ellipse, because it is not the same distance all the way around, that's where these A and B values come into play. Your horizontal distance from the center to the edge is called your A value. And your horizontal distance from the center to the edge up and down is your B value. So this is A is horizontal distance and B is vertical distance. So in my first ellipse here, I find the center point to be the point 1, 2. My A value is my horizontal distance, so I just count 1, 2, 3, 4, 5 over, and 3 up. And then I write my equations. It's going to be x minus 1 squared over, I have to square this and get 25, plus y minus 2 squared over 9 equals 1. Just like that. Should be no problem. Just like, and you can go ahead and do number 2. Very similar. It happens to be a vertical ellipse, but the process is the same. And then for number 3, just like we did on circles, it's the same thing. It's centered at 0, 0. So when I count my vertical value and get my horizontal value and get 6, my vertical value and get 2. When I plug in 0, 0 to my equation, there's no reason to write x minus 0 because that just is 0. So I'm just going to write x squared over 36 plus y squared over 4 equals 1. Down at the bottom, just like we did for circles, now they've given us an equation and we're going to graph it. So first thing you do is find your center point. Remember, when you're taking values out of parentheses, the sign changes. It's positive 3, negative 2. So I'm going to go ahead and graph that point. My horizontal value, my A value is this. Take the square root, so it's going to be 4. Count over 4. Both directions. You do the same. That gives me 2 vertices. These are called vertices, and they lay on the graph. So that gives me the vertices negative 1, negative 2, and 7, negative 2. That's what these 2 dots are. Now I use my B value, take the square root of that 36, and get 6. Count up and down. I'm going to go ahead and sketch my ellipse. And that gives me the vertices, let's see, looks like 4, oh, nope, sorry. 3, 4, and 3, negative 8. And there's my ellipse. Alright, so on the next page, just like we had on the snowman page with the circles, they want you to find the equation based on what you found. They did D for you. They found the center point to be right here at 4, 5. Your horizontal distance is 2. That's where the A comes from. Your vertical distance was 1. They counted up 1. And then they just plugged it into the formula. Don't forget you square these underneath. So you can go ahead and do E, F, G, and H. And I think you could probably go ahead and do both of the problems on 6 as well. Now next, on 7, they're going to have you use the equations down here at the bottom and graph one. So we'll go ahead and do one of those. Let's see. The center point here is going to be the point 5, negative 1. So right here, square root of this is 3, so it's 3 each direction. Square root of this is 5. And I draw my ellipse. That wasn't very good. I didn't even go through the point. There we go. That's a little better. Alright, so there's my ellipse. That was A. You go ahead and do B, C, and D all on this same grid. Then let's see, this last one down here, they're just asking you what these vertices are. So they're asking you to find exactly where Q is. And you get all the information you need right here in the equation because you can find A here and B here. Remember, these are squared, so you have to take the square root. And you just add that to the center point, both horizontally and vertically. All right, so on the back, there's a little bit of notes on the back, vocabulary that is specific to the ellipse. Ellipses don't have radius. They have axis. They have a major axis. That's whatever's biggest. So it might be horizontal and it might be vertical. The other axis, hold on just a second. The other axis is called the minor axis. So that makes sense, right? The bigger is the major, the smaller is the minor. So the one here on the left has a horizontal major axis. Now if you think about this, this makes perfect sense. That A value represents from the center to the horizontal edge. So if I want to go from one horizontal edge all the way across, it would be from here to here is A, and from here to here is A again, or 2A. Or you just take that A and you double it, and that'll give you your major axis. If it's a vertical hyperbola, it's the B value that you want to double. So that part's pretty easy. But there's another spot on an ellipse that you need to know about, and that's the focal point, or the focus. And there's one on each side. That is where we put our tape. If you were not here for the string exercise that we did with the ellipse, remind me and I will show you real quick, because it does kind of help to know what those focal points are for. But in order to find a focal point, you have to find this distance, this focal length. It's called C. And you just use this formula right down here in the middle. And you just plug the values in to find it. Once you find C, you add and subtract C to your center point. So you'll notice that they're called foci, and the formulas are right down here. The one on the left is for a horizontal ellipse, and the one on the right is for a vertical ellipse. So let's do, let's do D together, because of the four down at the bottom, D is the more difficult. So the first thing I'm going to do is find my focal length by using the formula at the top. So my formula is the absolute value of A squared minus B squared. And the reason they have that absolute value sign there is just so that you know not to worry about any negatives that might happen. So in this case, that's going to be 36 minus 100. And this is exactly what they mean. This goes negative, but those absolute value signs tell me not to worry about it. There are no imaginary lengths here. It's just going to be 8. So my focal length is 8. My center point on this particular circle happens to be the point 3, 4. So this is a vertical hyperbola, and you can see they put my foci up here right above and below the center point. Your foci always lie on your major axis. So since this is vertical, my foci are going to be up and down from the center point. So I'm going to go to my center point, 3, 4, and I'm going to go up 8, because that's my focal length. Which means my first focus is going to be 3, 12. Because up 8 from 4 is 12. Now I'm at 3, 4, and I've got to go down 8. So it's going to be at the point 3, negative 4. So that's how you find your focal length. Now if I was doing A or C, I would go to my center point, and instead of counting up and down, I would count right and left, whatever my C value is. Because your foci always lay on your major axis.